Okay, so this is question number 4. We are given the following graph. So let me draw this graph. This is the x-axis, this is the y-axis. Figure is not to scale, there is a hit. And there is a hit. Now this point is 6 units. This point is, figure is not to scale, this is just an approximation. This point is 3 units and this point is 1 unit. Now question number 1. This line is L, this line is M. We are asked to find the x-intercept of L. Now if you see, the x-axis is hit at 6. So the x-intercept is going to be 6, y is always going to be 0 for x-intercept. Okay, so that's the solution for this question. Next, they are asking us to find the y-intercept of M, right? Now this point where y-axis is being hit is on the figure, on the question paper it shows as -2. So y-intercept means x is always 0 and the value that is shown here on the y-axis, that should be the value written here. Okay, so that's a solution for the question. Now the equation of, let me write this. The equation of L is x positive 2y negative 6 is equal to 0. Find the value of k given that the point 9, k lies on L. So how are we going to do that? Okay, so this is given L is x positive 2y negative 6 is equal to 0. So this passes through, or I would say the line is passing through the point 9, k. Okay, so in place of x you substitute 9, in place of y you substitute k. So 9 positive 2 times k negative 6 is equal to 0. 9 added with 6 is 3. Positive 2k is equal to 0. So 2k is equal to -3. So k is equal to -3 over 2. Or k is equal to -1.5. So that is the solution. Okay, this is the next question. Find the equation of M in the form of y is equal to mx plus c. Now the line M passes through 1, 0. You see here, it passes through 1, 0. So this means x is equal to 1 and y is equal to 0. So if I were to take this as 2, therefore 2 can be rewritten as 0 is equal to m times of 1 positive c. Okay. Now from here I can write m is equal to negative c or c is equal to -1. Now this is a very important step that will allow us to get the slope once we get the constant c. So this is actually, we get the constant c. From getting the constant c we will be able to get the slope. So that is the idea here. Now slope is important because that's the key value that will answer the next question. Okay, the next is you look at the y-intercept. Y-intercept is -2. The line intersects the y-axis at y is equal to -2. Now this intercept gives us the value of the constant. So this means c is equal to -2. Now if I were to go here, if I were to name this as sum 4, so this means from 4, in fact I will take this as I'll take this as 4, it's more appropriate. So from 4, m is equal to negative of negative c, right? M is equal to negative c, c is -2. So m is equal to negative of -2, which means m is equal to 2, which means slope of m is equal to 2. Okay, that's a very important point. So therefore the equation of m, y is equal to mx plus c, is going to be y is equal to, slope is 2 times x and c value is -2. Okay, so having got that, let us move to the next question. It says show by calculation that, this is the next question, show by calculation that m and l are perpendicular. Now we have been given the equation of L, right? Now I'm going to use the space here. So from L you got x positive 2y is equal to 6. I'm going to take the 6 to the other side, and then 2y is equal to, move this x to the other side. So x, negative x, positive 6. Then you divide by 2. You get y is equal to -1/2 times x, positive 3. Now this is of the form y is equal to mx plus c, where m is equal to -1/2, right? Now go back here. Look at the slope. I'm going to use a space here. Since slope of m is equal to 2 and slope of L is equal to -1/2. So if I were to take this as m1, m2, we see that m1 times m2 is equal to 2 multiplied with -1/2 is equal to -1, right? Now since m1 m2 is equal to -1, product is equal to -1, this means m is perpendicular to L. And if you want, you can also, instead of saying it as m is perpendicular to L, you can also state it as L is perpendicular to m, right? Either like this, either this. So hence proved. Okay, so what have we done? We have extracted the slope of L, then compared it with the slope of m, right? And then represented the slopes as m1, m2, took the product and found it to be equal to 1, and then we make the conclusion. Okay, all by calculations. Now the next question is, if line L and line M represents a pair of simultaneous equations, then find the solution. Okay, find the solutions. Now this is L. L is x positive 2y negative 6 is equal to 0, and M is this, right? So y is equal to 2x negative 2. So I'm going to take this as a 5 and this as 6. So from 6 you can actually, or I would say using 6 win 5. I'm going to write it like this. Using 6 in 5, we get, so in place of y I will substitute this. So x positive 2 times of 2x negative 2 negative 6 is equal to 0. So x positive 4x negative 4 negative 6 is equal to 0. X positive 4x negative 10 is equal to 0. X added with 4x will give me 5x negative 10 is equal to 0. Move this 10 to the other side. You get 5x is equal to 10. Divide by 5. 5 gets cancelled. 5 divides here 2 times. So x is equal to 2. So what you do is you put x is equal to 2 in 5. So 2 positive 2 times of y negative 6 is equal to 0. 2 added with negative 6 is negative 4. Positive 2y is equal to 0. So 2y is equal to, move this 4, negative 4 to the other side, you get positive 4. Divide each side by 2. 2 divides here 2 times, so y is equal to 2. So therefore, the solution set is x is equal to 2 and y is equal to 2. If you want, you can perform the check. Y is equal to 2x negative 2. So you substitute y value is 2, x value is 2. 2 times of 4 negative 2 is equal to 2. You already have a 2 on the left. So this means left hand side is equal to right hand side. Hence, check holds. Right? So that's the solution for this question.